So today we are going to do the experimentation of connecting two solar panels in series connection. Okay, so these are two solar panels of same rated connected in series connection. So these are two solar panels connected in which connection? Series connection. Totally how many panels we are going to connect today? So 1 2 3 4. So these two solar panels are connected in series connection, these two are connected in series connection, that is called string 1, these two are called string 2. So now totally string 1 and string 2 is once again connected in parallel. So totally we are generating 80 plus 80, 160. So 160 plus 80 plus 80, 360, or 8 into 4, 8 fours are 32, around 320 watt solar system we are going to generate. Okay, so I am taking so from this is one end of the panel, so I got one positive and negative. So this is another end of the one more panel, I got positive and negative. So how I have to connect those two panels? Series connection. Series connection means how to connect. So take your diagram, give one white paper, book. So how to connect them is, so you have, this is one solar panel, this is another solar panel. So you have positive terminal and negative terminal, positive terminal and negative terminal. So we have to connect negative to positive, resultantly you are going to get one positive and one negative. Okay, so see here, so now which two terminals you shorted? Negative and positive. You see here, this negative and positive is shorted here. Okay, so this will act as a string 1. So a second string we are going to construct like this. Okay, so we have panel 3 and you have panel 4. Okay, so here you have one positive and one negative, one positive and one negative. So the negative is connected to positive. So this is nothing but from solar panel 3. So this is solar panel 3, that is solar panel 4. So you got one positive and one negative, one positive and one negative. So how we are going to short circuit? Negative is connected to positive. You see here, where is the negative? So this negative is connected to the positive, this negative is connected to the positive. So the resultantly what will happen? So how many I got the resultant? This is one output. So this is nothing but positive and this is nothing but the negative of one set. So resultantly this is one positive and negative is the resultant of what? The system. So here we are connected. So see the rating of the solar panel. What is the rating of the solar panel we have here? So already we discussed. So write down the rating. It is an 80 watt solar panel, 80 watt solar panel, and VM is 17.25. VM is 17.25 and IM is 4.7. IM is 4.7. So now what are you going to do now? This is 17.5 and this is 17.5. How we connected them? Series connection. By using this link, we connected them in series connection. So when you connect them in series, this is 17 and this is 17. 17 plus 17. So how much is the resultant voltage you are going to get? 34 volts. Now in the meter, how much it has to indicate? 34. So this is one positive and this is one negative. You are going to get how much? 34. Okay, so similarly here you join here, so from this terminal and from this terminal how much you are going to get? 34. So now again, so here also you have two panels. So this is generating an VM of 17, this is also generating VM of 17, and what is the resultant voltage you are going to get? 34 volts. Now this 34 volts I am connecting to the positive, this 34 volts I am connecting to the negative. The positive is joined, negative is joined. If then automatically I can say that string 1, string 2 are connected in parallel. So here I had used one wire to short circuit. So this is that wire. So for negative parallel and positive parallel. So that's why we buy this latest how to interconnect to make you to understand. Okay, so now resultantly how many terminals you got? One is one positive terminal, one is one negative terminal. So we are going to bring the positive terminal and negative terminal, we are going to connect the voltmeter in parallel, and we are going to take from here and we are going to connect to an ammeter and we are going to connect to an resistive load to the negative. So from the positive end, so the resultant positive is this one, the resultant negative is this one. We are connected to an isolator. For example, any short circuit occurs due to internal, or if any short circuit occurs inter between, so we protected it by using an MCB. okay, and this is primary protection. Secondary protection, again we use a fuse, okay. So here inside you have a fuse protection for more safety. Why? Because this solar panel itself is around 20,000 rupees, and this meter and this rheostat is around 20,000 rupees. So to safeguard the equipment, we are using primary protection and secondary protection, okay. So and what are the resultant outputs you got? So what is the resultant output of this panel you have got? One is positive, one is negative. So you got one positive and one negative. I'm connecting an voltmeter in parallel. So now you see here, I'm going to turn on the equipment. As soon as I turn on, how much voltage you are going to get? I had connected in the range of what? 60. Why? Because so I have to measure 34 volts. See here how much it is showing now. Approximately 17, 18, 19, 20. So it's approximately 18 volts. Okay. So 18 volts means how much? 18. And what is the scaling factor connected at 60? 18 into 2 is how much? 36. Approximately 34 to 36. So now this voltage, what it is indicating is nothing but how much? 36 volts or 34 volts. Theoretically it is 34, but due to this we are having more, it is around 3 o'clock, we are having more voltage generation. So rather than generating 17, it is generating 17.2 volts. That's why it is adding one more round figure. So to generate 36 volts. Okay. So now you got 36 volts, and now I'm going to connect this ammeter and rheostat in which position? Series connection. So I had got the voltmeter. From the positive, I'm going to connect to the ammeter. So I'm taking the positive terminal of this and I'm connecting to the positive, and current is entering at positive terminal of the, current enters to the ammeter which terminal? Positive terminal. It leaves which terminal? Negative terminal. So from the negative terminal I had connected to the rheostat input. So this is nothing but the rheostat input. So now current enters to the rheostat input and current leaves at which output? Output. So here the current is leaving, and directly from this negative are connected to the negative of the voltmeter, directly is connected to the negative. Now in such a way that the ammeter and rheostats are forming an closed path for the current flows. Now initially this is the input and this is the output, and now this is the input and this is the output. What is the position of the rheostat now? Maximum by R is equal to, the formula is rho L by A. So now what is the length of the rheostat? Greater. So length is higher, automatically. What is the resistance of, what is the position of the rheostat? Maximum. What is the formula for current? Current I is equal to V by R. We kept the resistance in which position? Maximum. Then how much current will flow into the equipment? Low current. So that's why we'll start the experiment with low current. Okay. So you see here, we are going to start the experiment with low current. How much amount of current? We are connected in the range of what? 10 amperes. Okay. So it is only showing 0.2 into 2. 0.2 into 2 is how much? 0.4. So take the readings, voltmeter, ammeter readings. Write in the tabular column, in the observation you try to fill it. So write down the voltage rating. 17.8 into 2, 17.8 into 2, and here current is 0.2 into 2, 0.2 into 2, the first set of reading. Second set, how we are going to do? So now we are changing the resistance from maximum to minimum. If reduce the resistance, current will increase. Okay, so it is having 0.3, I am keeping some 0.4. Write down. So voltage is 17.7 into 2, current is 0.3 into 2. Write down. Voltage is, so we are increasing the load, automatic what will happen? Voltage will drop. So now it is 17.7, sorry, 17.7 into 2, current is 0.5 into 2, 0.5 into 2. Next reading. So we'll try to proceed only maximum 2 amperes. Why? Because we have safety for only 6 amps. Okay. So nothing will happen when you come closer. These terminals will act as an short circuit. It will produce heat and it will damage soon. Why? Because we are having how much load? Approximately 320 watts is there. That's why it will damage. So now I am going for 0.6 amps. So voltage is 17.6 into 2, and current is 0.6 into 2. Next one, I am going to 0.7. 17.6 into 2, this is 0.7 into 2. So this is 17.5 into 2, this is 0.8 into 2. So I am stopping here to 2 amperes only, I do not want to load the equipment. So 17.5 into 2 and 1 into 2. Okay, so you see here this is already getting overheated, so I do not want to heat it, so I am reducing the load. When you reduce the load, resistance is maximum, current is minimum. You just touch it, you can see anyone come and touch it, you see that the heating effect is there or not. This is acting like an which load? Resistive load, 100% resistive load. Why? Because this much amount of power is generated. So now you have to bring the rheostat to which position? Minimum resistance position, and you have to turn off the MCB. Okay, and next how to start the experiment is just turn on the supply. Now you will be given chance, you can do the experiment. Okay, so turn on the equipment, automatically the voltage is 34, it is showing it as 17.5 into, I mean 17.68 into 2, approximately 36 volts, and we are connecting to the which position? Maximum resistance position, current is minimum. Slowly vary the rheostat in terms of 0.2, 0.3, 0.4, 0.4, this is okay. Next 0.5, 0.6, 0.7 and 1. So you can see here it is getting overheated. Okay, so then come to which position? Maximum resistance position. This is how to load. So you can connect a load or you can connect an bulb. Okay, when you connect a bulb, it can give an appearance for you also. Okay, or you can understand it is connected to an resistive load. So while you are turning off, you have to keep in which position? Maximum resistance position. Automatically current will reduce in the meter and voltage will be same. Whatever may be the load, voltage will be same. Depending upon the loading, automatic voltage will decrease, and then turn off the power supply.